Hi, let's practice exponents. So I'm going to be giving you two batches of problems to do. This is the first batch right over here, and the goal is to simplify each expression as much as you can. And that means try and write the final expression here without using any negative exponents, okay? So only positive exponents. Why don't you pause the video here and try it yourself, then come back and we'll do it together. Okay, so let's try this together now. Let's look at the first batch of, here we've got the first four problems here. A to the fifth power times a to the third power, that's the same as a to the 5 plus 3 power, and that's the same as a to the 8th power. There we go, not too bad. This next one we can do the same way. So this will be b to the 3 minus 8 power, and that's the same as b to the negative 5 power. But when we simplify, it's very common where we don't want to include any negative exponents in our final answer, so we're going to have to write this as 1 over b to the 5th power. This way there's only positive exponents in our response. This one here is going to be the same as c to the 12 minus 3 power, which is the same as c to the 9th power. And finally, this one here, we have a power of a power, so we have to multiply these exponents together. We're just going to get d to the 21st power. There we go, that's the first four. Done. Let's do the rest. We've got three more right here. So this first one, we are also going to essentially distribute this 3 into that monomial term like that. And so we can think of this as 2 cubed times e cubed. But 2 cubed, well, that's just 2 times 2 times 2, that's 8. So this is the same as 8e cubed. Okay, there we go. This next one, we can also imagine sort of distributing this exponent in just like that. And so this is going to equal f to the 4th power over 2 to the 4th power. But what is 2 to the 4th power? Well, 2 to the 3rd power is 8. So we just need to multiply by 2 again. So that's going to give us f to the 4th power over 16. There we go. And the last one here. Here we can sort of take the reciprocal of both the numerator and the denominator to get rid of the negative exponent here. So this is going to be the same as 3 to the positive 3rd power over g to the positive 2 power. But what is 3 to the 3rd power? Well, that's going to be 3 times 3 is 9. 9 times 3 is 27. So this is 27 over g squared. Okay, so there we go. That's the first batch. Hopefully you got them. Let's look at the next batch of problems. Okay, so here's the next batch of problems. Again, you want to try and simplify each one of these, but they're going to be a little more difficult this time. Maybe take more than 1 or 2 steps to do. So again, pause the video, do your best, and then we'll try it together. Okay, let's try it. So here we have the first two. Okay, how do we want to do this one? Well, it seems a little bit complicated, but I think the first thing I want to do is try and get rid of this exponent by essentially distributing it into everything that we've got here. So let's do that. So let's say that this is equal to 5a to the 4th power b cubed times, well, 3 cubed a to the 2 times 3, that's a to the 6th power, and then b to the 5 times 3, well, that's the 15th power, just like that. And now we can multiply everything here. So let's see what we're going to get. So this is going to be 5 times, well, 3 cubed is 27, right? So let's write this as 27. And so what we're going to get is 5 times 27. Well, what is that? Let's do that real quick. Okay, so 5 times 7, that's going to be 35. This is 10, and that's going to be 135. Okay, so this should equal 135. A to the 4 plus 6, that's 10. And then we have b to the 3 plus 15, that's going to be 18. Okay, there we go. This should be our final answer then for the first one. Let's take a look at the next one. Okay, so here, a very similar thing. We have all of these exponents that we can essentially try and distribute into that monomial term that's in there. So let's do the first one. We'll get here d, 2 times 2 is 4, and then e to the 3 times 2, that's going to be e to the 6th power. And then over here we'll have e cubed, d to the 2 times 3 is 6, over f to the 2 times 3, well, that's also 6. Okay, so we're almost there. And now we just have to combine. We have to multiply these across. Now, notice one thing that's going to happen here is this e cubed is going to cancel out with 3 factors of e over here. So this is just going to become e cubed on the bottom there. And that's the only thing that's going to cancel. Okay, so let's multiply the rest through. So in the numerator, d to the 4th times d to the 6th, well, that's going to give us d to the 7th power. D to the 10th power, 4 plus 6. And then in the denominator, we'll have that e cubed and f to the 6th power. Okay, I think that's it. We should be done with that one. Let's do the last two. All right, here we are, the last two problems. Now we're working with some negative exponents, okay? So remember, you can essentially just take something with a negative exponent and get the reciprocal to make it a positive exponent. And effectively what that means is we can take this e to the negative 5 and bring it to the denominator and make it an e to the positive 5. And this g to the negative 3 we can bring to the numerator and make that a g to the positive 3. So that's what we're going to do, right? We're going to say that this is equal to... well, okay, I'll just do that first. So this is 9g, and then we'll get this g on top, g cubed, over 3. Got rid of that. We'll bring this h to the 5th now. So that's h to the 5th times h cubed. Okay, see what I did there? So I took the negative exponents and I flipped them to the other side of the fraction. Now we can try to simplify this a little bit. Of course, 9 over 3, that's going to cancel. That's just going to give us 3. Here we're going to get g to the 4th power over h to the 8th power. Okay, there we go. That's the fully simplified version for that one. Let's take a look at the last one. So there's a few ways we can do this. We have a negative exponent out here. So I could distribute that through here as a negative, or I could just get the reciprocal of what's inside to make this negative into a positive, right? So I'm going to actually do that. I'm going to rewrite this as 6k to the 4th power over j all squared, okay? So that gets rid of the negative exponent, and now I can just have this positive exponent and sort of multiply that in essentially, right? So I'm going to get then 6 squared, k to the 4 times 2, well, that's 8 over j squared. And finally, 6 squared is the same as 36k to the 8th power over j squared. And now I should be done. Okay, so hopefully you got all of the same responses for these practice problems. If not, keep practicing, okay? These exponent rules should become second nature to you because we'll be using them quite a lot in a lot of our functions. All right, I will see you next time when we talk about scientific notation.